So if this angle here is 30, and you can tell that this forms a linear pair, so this is 90, that makes this one 60, since the two acute angles must add up to 90, so that when you add it to the other 90, you get 180. And the other thing is, you essentially have a larger triangle here as well, and that's 90. And with this one being 30, you know this one's 60, which then makes this one 30. So we have a couple of 30, 60, 90 triangles that we're dealing with here. And if we go to our program spec try, which is the third from the bottom, we see the two relationships that exist within these two kinds of special right triangles. So what I would do is actually redraw the larger triangle that has the only side that we actually know. So this 4 comes from this ABC triangle here, where this is 30, this is 60. And notice across from the 30, we call it x. Across from the 90, we call it 2x. And across from the 60, we call it x root 3. Well, if x is 4, that means that 2 times 4 is 8. That also means that 4 times root 3 is 4 root 3. So I'm going to go ahead and label that in the actual figure here. Now, the 8 that I'm referring to goes from A to B, which means all the way here. If we could figure out what this portion is, we could just subtract it from 8 and we'll be left with this x value. So let's see where we can go from here. So we'll essentially have to look at this triangle now with that 30, 60, 90 relationship. Again, across from the 30 is x, but I'm going to use a different variable because we already used it here and it's already down here. So let's avoid using x too much here. So let's go to call it y. Across from the 90 we said is 2y, and then across from the 60 we would say is y root 3. All right, so they are wanting this value. So if I divide by 2 here, I find that y is 2. Well, if y is 2 and this whole thing is 8, I could do 8 minus 2 and I obtain that x is 6.